let's discuss the unambiguous range and unambiguous Doppler velocity. As you might have noticed in the previous two graphs, these two equations, which describe what unambiguous velocity and unambiguous range are, both depend on the PRF, pulse repetition frequency. Additionally, one of them depends on the wavelength of the radar. For each frequency band that radars operate within, there is a specific connection between the unambiguous range and the unambiguous velocity, which is defined by a particular line on the graph. Let's look at two different examples to understand this better. But before we do that, I'll mention this: one key takeaway from the graph is that you can't have it all. You can't unambiguously measure targets at arbitrary ranges and arbitrary radial velocities with just one set of pulses. We'll later cover how to unravel these ambiguities to measure velocity accurately, but for now, let's consider the first two examples. First, let's look at air traffic control radar. Suppose we want an unambiguous range of just under 150 kilometers, which corresponds to a PRF of about 1000. If we build the radar at 3 GHz, we'll get an unambiguous velocity of around 60 meters per second, or about 100 miles per hour. However, aircraft flying around terminal areas move much faster than that. So, with an individual coherent processing interval using 1 PRF, we can achieve unambiguous range, but the velocity measurements will be ambiguous. As I mentioned earlier, using two sets of PRFs that differ by 10 to 15%, you can unravel the ambiguity in Doppler measurements. Now, let's take another example. Suppose an airborne radar wants to have an unambiguous range of about 100 kilometers. To achieve a reasonable beam width with an aperture of only 3 feet, you would need to use a high frequency, such as 10 GHz, with a wavelength of about 3 centimeters. In this case, the radar will have a very low unambiguous velocity, around 30 kilometers per second. If we try to increase the unambiguous velocity to a high value, like 1000 kilometers per second, the unambiguous range will become very small. This means you can't have your cake and eat it too. Radars typically operate in a way that both range and velocity are somewhat ambiguous, and you have to manage these ambiguities carefully. That's the main takeaway I want to leave you with. Thank you.